Okay, so what we're looking at here is the main plant room energy centre that we've been talking about that's going to provide all the heating around to all the flats on the site here. And what we're looking at the moment is the combined heat and power system, the CHP unit. This basically is acting as the lead boiler in the system, provides both heat and electricity. Basically what you've got inside the unit is an engine, which instead of being driven by petrol or diesel is driven by gas. And basically that gas engine then is basically driving a large electrical generator on the back end of it. This unit generates about 70 kilowatts of electrical energy, and it equates to about 140 kilowatts of thermal energy that will come out of it, of heat energy that comes out of it. The heat energy then can be used alongside the boilers to feed heat around the system and up to the flats. The electrical energy in this particular installation is going to be used to feed into what's going to be used by ASDA, electrical energy that's going to be used by ASDA when they occupy the site. But it could be used anywhere or even exported back onto the grid again. But on this particular site, that's where it's being used. Okay, so these do need a fair amount of maintenance, and part of the agreement of the guys who supply it is they come along and do a maintenance, so you're looking at a fairly regular schedule of oil changes and as you would do a servicing on schedule on your car in terms of being looked after over so many hours of operation. But there is a control system on it, and that will report back to the BMS and out back to energy who supply the unit to let them know when things need doing to it as part of that sort of maintenance schedule. Where the heat from the CHP is then supplied is via a set of pumps down here into the large thermal store at the back there. So that's where the heat's collected from the CHP. The reason for the store basically is so that as heat is generated by it, it's drawn out from the store. But if there's no heat demand for a period of time, you can still go on heating up the thermal store, keep running the engine for as long as we can. Then as heat's drawn away again, it will draw down on the thermal store and we can keep the CHP running for as long as possible. Okay, so the pump sets here, this set of pumps right in front of us are basically pulling the water out of the CHP thermal store and supplying that into the system. So the header pipe work above us. So that's what those pumps are doing, is pulling it out of from the CHP and supplying it into the system. The ones on the far side are basically circulating the water then from the boilers into the header of the system as well. So there's a circulation of the primary round from the boilers and up into the header pipe work itself. Okay. The two sets of pumps on the far side, as I said, the large set are then pulling the heat out of the headers and off up to the risers around the heating systems and off to the flats. The smaller set of pumps to the far side there are then pulling the heat out of the headers and feeding it round to the plate heat exchanger for the ASDA side of things. Okay. So those are not operational at the moment, whereas the ones for the residential area are very much underway and operating now. What we've also got above your heads literally are two pipes there with dead ends on them, and they're basically for a provision for connecting into a future district heating system, which should be a Barking wide area district heating as I understand it. So that would in effect take over from the boilers and the CHP in here if and when that comes to fruition. But that provision is already built into the system to take over from that. The main heat providers then are the two red boilers behind you. So we've basically got two 1,000 kilowatt boilers there. So that's the main heat that's going to be distributed around the building. So again, if we have got a failure, 1,000 kilowatts goes an awful long way. So there's a good bit of heat to pass around the building. Those are gas-fired boilers that are going to be again, need a servicing routine.
BMS panel is provided by Cura Energy for Woodford Heating. The panel is supplied with a Siemens control system and consists of a number of hand and auto operating switches, and all of the equipment within this energy centre is fed from this panel. So any faults or equipment not working in this panel will either relay the information back to this panel or will indicate a lamp on this door to say that it's in fault, requires attention or requires maintenance. On here at the moment we have residential pumps, boilers, primary pumps, the CHP pumps, Asda secondary heating pumps, and the plant room supply fan to bring fresh air into the plant room. We also monitor the fire alarm, a stop lock which is at reset on the main entrance to the room, the pressurisation unit, general extract fans for the apartments, the CHP unit as to whether or not it's enabled, whether it's in fault or whether it's actually available to run. And finally, the car park extract system also indicates a fault back to here, which can be relayed to the concierge desk to tell them there's a fault with the car park extract system. All of the switches on the panel have a manual, off and auto status. If for any reason the computerized section of this fails, you would still be able to operate the site and building under manual, so you could still maintain heating to all of the apartments and extract ventilation, etc. for the building. Normally when you come in here, all of the switches will be in auto. Some of the switches you'll notice are in auto and the green lights aren't on. These are units that are in standby should the main unit not be operating. So where we have 2 pumps, we have 2-1-2-2. Normally 2-1 would be the pump that would be running for this week. Each week it will change over to the other pump, so we get even wear and tear on the equipment. So if you came in on, say, week 1, all of the 2-1s should be running. If you came in on week 2, all of the 2-2s would be running, unless there was any fault with any of the pumps or any of the flow switches, in which case it will default back to whichever pump was working. So that way then you never get a building where there is no heat being circulated, because we have 2 pumps, there's always a backup. For local engineering purposes, we have a localized keypad. It's password protected, so people can't mess with it. The password would be available within the O&M documentation. It's not something we normally issue to people unless there's a requirement for them to have the password, because there is the ability to switch plant off, change settings, or make the plant inefficient. So we prefer, basically, if you have a maintenance company, we can give them the password, they can then make adjustments that they feel are necessary for your building, and then obviously they can monitor the system from this point as well. To relay the faults back from this panel to the concierge, what we have is a head-end computer with installed software from Siemens. That software and that PC are tied to this system. Unfortunately, you can't change the PC, you can't change the software, and we don't recommend installing any other software on that PC. That PC operates a database to store when the alarm happens and when the alarm is reset and who reset the alarm. So if you have a maintenance company of A.N. Smith were doing your maintenance, they could come in, fix the alarm, sign in as A.N. Smith at 12 o'clock on the 12th of December, and there would be a record of that stored on that computer, which is why we don't recommend putting anything else or using it for any other purpose. Because in future, if there's a constant fault and the installer is called out to rectify that fault, he'll want to know how many times it's been in fault, who reset it, why they reset it, and etc., etc. And all of that can be stored on the head-end computer. There's 2 parts to this explanation, is that we need to go and have a sit with the head-end computer and just explain that as well. This is the functioning end, the hardware end. There's a software end, which is the concierge's monitoring of those alarms and noticing that it's in alarm and that he needs to get an engineer out to come and have a look at the faults. This is the green screen energy display for the educational purposes of the plant room. It currently consists of 6 slides containing information to the CO2 used, CO2 produced by the building, the energy, the water and the gas used by the building, and an overall summary of the state of the green credentials of the building. Other benefits with this are, at the moment we are currently scrolling a message which just tells you what the outside air temperature is. If you wanted advertising banners, things like Christmas is coming, those sort of items. There's a text file that can be edited that the banner will then display whichever text you type in. So if you said we have 7 flats available and you wanted it to scroll across while people were looking at the energy screen, it can do that as well. First screen is the consumption for the building. This showed electricity, gas and water. Second screen is the heating provided by the CHP unit. What it will give you is the consumed amount of heat and the generated amount of heat. Until the system is fully running and the building's occupied, these values will change dramatically, and then you'll get a nice graph of we've produced 60 kilowatts of heating and we used 60 kilowatts of heating. If you get to the summer, what you may well find is that the green section on the top will be larger because you're not using all of the heat produced by the CHP. Unfortunately means you're working a little bit inefficient, but it's there as an energy display and educational reasons more than it is anything else. After the heating, it should show us the electricity produced. We have CHP electricity. At the moment, we're not producing any kilowatt hours of electricity because the CHP unit's not running. When it is fully running, you'll be producing electricity that your building will be using in the sort of general areas, the flats. It's divided into the national grid supply. So the whole building uses less electricity from the national grid. Bonus for you, because you don't have to pay them lots of money, and it's free because you get free heating on the other side of it. So you get sort of heat and electricity for the small amount of gas that you put into the system. Makes it very efficient, also means you save money on your gas and electricity bills for the whole building. Next one we have is carbon dioxide and NOx emissions. These are the two things that the European Union monitor everybody on. Carbon cost is based on how much it's costing CO2 per kilograms per day. And then the amount of carbon saved is your solar PV, your green roof and green walls all absorb CO2, so that's a saving. And all of those are calculated and given as values, and again another graph which tells you how much you produced and how much you saved, and that all goes towards the last page on here, which will tell you an equivalent. We've used miles driven in a car as an average 2-litre car. The last picture is the carbon target, carbon used this month and the carbon last month. There's a random number of energy saving photos that will load up each time this page cycles round. So this time it's come on with the turn off your lights. There are a large number from the Carbon Trust on the server already. If you want to put other energy saving from the Granger group, if they have a particular one, they just simply need to be saved in a folder on the server as a JPEG, and it will automatically randomly pick one each time the page loads. So every 10 minutes you'll get either the same image or a different image, but it's a random selection. But they're just there as a sort of push the green energy saving for everybody and anybody that's looking at the screen. Back to the main consumption, we have main gas total, main electricity total used by the building, and we have a current month used. Same for the gas, current month used, same for the water with the building and current month used. So you get a general gist as to how much the building's used over a year and how much it's using each month.
My name is Dylan Pepper. I'm here on behalf of Biotecture to explain the irrigation system for the living wall outside. It basically works of starting at the start point of the break tank. This is the water tank that takes water from the fresh water. You need to have an air gap between the supplied water and the water for the irrigation system, because it goes, next point of call is to go through the dosing unit. The dosing unit doses the living wall with nutrients and feed, which is mixed at 1 to 500 parts. It then continues through the line into the inline filter, back through to the flow meter, which gives us very detailed information on how much water is being supplied to each of the panels. Then it gets divided off into the 4 zones. There's 2 zones for the upper and lower section of the living wall, along with the screens and some beds up on the rooftop area. All the information is fed back up to the Heron controller here, which is monitored online. So this allows us to know whenever the wall's overwatered, underwatered, where there's a leak, there's a blockage. Also gives us the opportunity to change the irrigation cycles remotely away from site for changing of seasons, frost and so forth. As far as in-house maintenance of the living wall system, all that really needs to be known is if there's a problem, what to do. And in the case of this, it's to turn the power off and to call someone who is in charge of the maintenance for them to come out and deal with it. Up there we have, I believe, 1,800 plants, which come at quite a high cost to replace those. So therefore, no one who's trained should really get involved and touch this, because then that makes them liable for those plants if anything done here causes damage to the plants out there. So as far as the ongoing maintenance for this goes, two things to know is A, to turn that power off if you have any leaks out there, and if you have any leaks in here, to turn the water off at the source here. So as far as maintenance for the building goes, those are your main 2 points there: to turn the water off and to turn the power off. Let your maintenance provider know that there's an issue and have them come out and deal with it. I'd say at no point should anyone be trying to tamper with this, because they are quite bespoke and unique to the living walls themselves. There's potential for the human error of the timing of the irrigation system, and that's part of the maintenance for them to be taking moisture content and programming it. As far as overflowing from it, the way that the panels are made up of polypropylene with Grodan inside. Grodan is like an agricultural rock wall that absorbs the water, but it also absorbs the amount of water it requires. After that, it will flush through and go into the variegating membrane, which draws the moisture from the panels into the membrane, then down into the gutter and away. So it's any water that would come off the face of it in a saturation point would be minimal. Like, it wouldn't cause damage, it wouldn't cause a flood. It's all designed to be internally watered and come out through the guttering and to be taken away. You may notice the plants are too wet and it'd be turned down, but once again, if for any reason it was excessively flowing, we'd get a leak alert from the irrigation system, and one of the maintenance team would come out and deal with it. So although there is a potential in something like a sticky valve that stays open and it keeps on flowing with water, we'd have the alert before anyone on site would really realise, and it'd be rectified. And as I say, it all flows into a gutter and is taken away. So as far as pooling or anything like that, is minimal to little chance of that actually happening. The majority of the visits will be just to take moisture content, to make sure that the walls are being watered correctly, and also to look out for pests and diseases or any infections that might be taking place. Other than that, being an outdoor wall, we're about planned maintenance. And if you time the maintenance correctly, i.e. a spring cutback in early spring and a midsummer to early autumn cutback, that will give everything that the plant needs. The key is for size management, so they don't become excessively large. And if you time those two maintenance visits, that's about all the maintenance they need, with the exception of if you have any pests or diseases which therefore need extra cutbacks and replants. So there'll be additional deadheading and sort of grooming of the wall, but really there should be two planned spring and autumn cutbacks, and that should be sufficient for an outdoor wall.
Excellent. So what we've got, basically we're in the tank room for the cold water supply for the building. So that's what we've got here. Obviously is the cold water, the main cold water tank. So the cold water supply is feeding into there, out of the tank to the booster set. So we've basically got 3 pumps within the booster set. So basically it'll just ramp up as demand for cold water in the building increases. The more pumps will come on. So we've got basically a duty assist pump set. So we've just got 1 pump modulating off and on, just a very small amount of water usage at the moment. If a lot of people turn the taps on, then you might get 2 pumps running. If we're running flat out, the third one might well then kick in to supply enough pressure to get cold water up to the furthest flat, should demand dictate. I've obviously got some redundancy there as well, so if one did break down, there's still pumps to run to keep that water supply going out to the properties. If there is a problem with these pumps, then the control box here will send a signal back to the BMS then to give us an alarm signal to say there's a fault on the system here. They could then come and look at the panel on the unit there and see which is the pump that's gone into fault. Shouldn't be any regular need to come and look in this area. It should sit there doing its job automatically until such point as a service is required. The other item we've got in here is the scale inhibitor. So this is what we were saying about earlier about reducing the scale. So the electromagnetic unit is, and that's the control panel on the side there, is basically helping to reduce that amount of scale that might be distributed then out around the system. So on this side of the building we've got the main incoming water supply. It's feeding the tank that we talked about earlier, and we've got the water meter here recording out the water usage for the building, and that will need reading to record that side of it. There's then a secondary meter which is down here, which is feeding, recording then the amount of water that's been used for the landlord's supplies within the building, so things like the green wall irrigation that we were talking about earlier on. And the pump set we've got here is basically a separate booster set just for those landlords' water supplies around the building in the common areas. Again, with its own internal controls, and it's a twin pump system, so we've got a duty and assist on there as well.